The distance between our extraordinary lead and the real world is 390 light-years. To put things in perspective, 1 light-year is equal to 6 trillion miles. We have set out on a quest that transcends time itself in humanity's unrelenting drive to solve the secrets of the cosmos, looking for solutions to timeless questions woven in the fabric of creation. Recently, the unblinking eye of the James Webb Space Telescope caught a glimpse of a structure that existed before stars were born. More questions than it answers, this celestial object seemed to be older than the universe itself. Is the Big Bang theory to blame, or is there a way for a structure to exist that predates our cosmos? Come along on an excursion led by the James Webb Telescope's discoveries. The quest to solve cosmic mysteries has only just begun, and the secrets of a structure that is 13.8 billion years old lie ahead. An old star known as HD 140283 is located close to the Libra constellation in a far-off region of the universe, around 200 light-years away. As it swiftly traverses space, this star Voyager provides fascinating insights into its turbulent history. A dwarf galaxy that had previously called our Milky Way home was absorbed some 12 billion years ago, when it was still a young galaxy. But it is not just HD 140283's rapid travel that piques our cosmic interest, but also its incredible age. As one of the oldest celestial bodies we have seen, it is affectionately known as the Methuselah star, after the biblical character Methuselah, who is said to have lived for 969 years. The most recent computations indicate a slightly younger age of 14.46 billion years, with an uncertainty of 0.8 billion years, compared to the first estimate of an astounding 16 billion years. Astronomers were perplexed by this discovery regarding its age because the cosmic microwave background indicates that the universe is approximately 13.8 billion years old. The age of the star, the age of the cosmos, and even the precision of our dating techniques were all called into question by this puzzle. Let's dissect it. Determining the age of heavenly objects can be somewhat challenging. For example, stars are difficult to age because, like the sun, they are like perpetual light bulbs that retain their size, warmth, and shine for billions of years. By comparing variations in brightness and color with models that forecast how stars will evolve over time, astronomers act as cosmic detectives. One telltale sign is the speed at which a star spins. Stars slow down due to friction, just like a wheel. Astronomers have discovered an interesting technique known as geochronology, which involves comparing the spinning rates of stars at various ages. Flares and energy bursts on a star's surface are like a star's young exuberance. Stars also use magnetic gossip to reveal their age secrets. This show slows down when a star gets older. As space detectives, astronomers employ sophisticated methods such as asteroseismology. Listening to vibrations brought on by waves passing through a star's interior is similar to listening in on its inner dialogue. The age of the star is revealed by these vibrations. For example, using this cosmic eavesdropping, scientists estimated the sun's age to be 4.58 billion years. Let's go back to Methuselah's star now. By examining its cosmic environment, scientists were able to assign it a crazy old age. Thus the ancient aura surrounding it is not merely coincidental. The amount of bling, or heavy elements like iron, that stars possess can be used to categorize them. As a member of population 1 stars, our sun is somewhat of a metalhead. Methuselah's star, on the other hand, rocks fewer heavy elements and is comparable to an old-school rock star from population 2. Astronomers may play cosmic archaeologists and unravel the age stories of these celestial entities thanks to this starry blink-out. Now, consider a collection of stars known as the theoretical population 3, which scientists think could resemble the rare jewels of the cosmos. They are strong suspicions even if they haven't appeared under our telescope spotlight and are still hidden backstage. Given that they hardly contain any substantial elements, these stars may be considered the rock stars of minimalism. Let's go back in time to the early years following the Big Bang in order to comprehend this great lineup. Consider a cosmic kitchen that is primarily composed of hydrogen and helium, just like the fundamental components of the cosmos, which are roughly 92% hydrogen and 8% helium. Or about 75% hydrogen and 25% helium if we weigh them. The original 3 stars were the first to appear on stage in this cosmic symphony. Massive and hot, they quickly burned through their cosmic fuel, turning helium and hydrogen into heavier elements. These heavy elements were dispersed over the wide cosmic expanse by the explosion of these early cosmic giants. The population 2 stars, which formed somewhat later but still in the early stages of the cosmos, came next in line. Iron and other heavy elements were essential to their original materials. Numerous of them danced through their star life cycles, contributing more heavy elements to the global mix and exploding as supernovas. Ultimately, enriched gas clouds mixed with remains of the previous population 2 stars to form the population 1 stars, which included our Sun, which arose as cosmic latecomers. More heavy elements were added to the cosmic formula when some of these population 2 stars likewise went out with a boom. The key question now is whether the Key Bang theory is thrown a cosmic curveball by this fantastic story. The twist is that, despite the uncertainty, there is a 70% likelihood that the ancient celestial wanderer, the Methuselah star, is between 13.66 and 15.36 billion years old. There is a 30% probability that the age of this old celestial wanderer is defying cosmic laws, and the lower end even corresponds with the age of the entire universe. In a similar vein, there is a 15% possibility that it is not only a bit unconventional but also younger. It's statistically possible to imagine rolling a standard 6-sided die and hoping for the coveted 6. Nevertheless, despite these cosmic hiccups, it is undeniable that the Methuselah star is the granddaddy of stars and not just a cosmic veteran. We were able to assign it a fairly accurate age tag. This is where things start to become bizarre. Let's reverse the cosmic script rather than pondering how the Methuselah star may be a few billion years older than its galactic companions. What if the cosmos is older than we previously believed? Comprehending 13.8 billion years is akin to attempting to comprehend the immensity of space. Earth wouldn't even be able to join the heavenly celebration until the final seconds of December 31st, if the entire history of the universe were turned into a cosmic calendar, with the Big Bang serving as the most spectacular New Year's fireworks. Human recorded history, well, that's only the last 10 seconds, a blip in time. By examining ancient starlight that was created a few hundred million years after the Big Bang, our stellar detectives are able to establish the age of the universe. Redshift is the cosmic transformation this light undergoes as the universe expands. After calculating expansion and distance, astronomers determined that the universal age was 13.8 billion years. Hold on, though, for the cosmic story gets more complicated. According to a cosmic whisper from the University of Ottawa, it's possible that the universe is 26.7 billion years old. Professor Rendra Gupta introduces a 1929 theory developed by Swiss astronomer Fritz Zwicky that is appending our knowledge of the cosmos. This idea is surprising because it implies that photons, which are light particles, lose some of their energy as they travel over the immensity of space and time. Gupta suggests a cosmic compromise even if this theory doesn't quite match what our telescopes have been able to observe. He believes that by combining this theory with our current understanding of an expanding universe, we can explain the redshift phenomenon in a way that is somewhat hybrid. It's no small feat to change the universe's age to an astounding 26.7 billion years, so buckle up. Paul Dirac, a theoretical physicist, came up with the idea of evolving coupling constants, which Gupta combines with the linked light theory to bring another flavor to the cosmic stew. This idea raises the possibility that the way particles interact has evolved over time. And hey, the cosmic clock has been adjusted by scientists before. Edwin Hubble believed that the cosmos was only 2 billion years old in the 1920s. Since then, we've improved our cosmic math and made significant progress. Doubling the age of the universe is equivalent to making a huge advancement in our knowledge of the cosmos. Let's take a moment to consider whether this new viewpoint will eventually become the standard for the universe. One thing is certain, the cosmos is a wealth of ancient wonders and limitless inspiration, regardless of whether humanity's documented history is a brief flip of 10 or 5 seconds in the vast scheme of the universe. There is an enthralling cosmic tango going on when we turn our attention to the Milky Way, our cosmic backyard. In contrast to their counterparts in other galaxies, stars on the periphery of our galaxy appear to be strutting their stuff in slow motion, according to recent measurements. The cosmic scoop, what is it? There are a few possibilities, and one rumor is that the Milky Way may be lacking in dark matter, the enigmatic cosmic component that affects the gravitational dance of celestial objects. Dark matter, the enigmatic material that is invisible to us but appears to be involved in a gravitational tug-of-war in the universe, is a cosmic riddle. The prospect that we have been viewing dark matter incorrectly, that is, that our cosmic compass is pointing in the wrong direction, is one that might upend our understanding of the cosmos. This is where the Gaia spacecraft from the European Space Agency enters the cosmic spotlight. It offers detailed information about the dance of about 2 billion stars in our Milky Way, acting as our cosmic detective. Consider it a lesson in galactic choreography. Astronomers are reconsidering their cosmic choreography notes in light of the satellite's accurate measurements. Our long-held beliefs about the velocity of stars at the furthest reaches of the Milky Way appear to be being challenged by their apparent slowness. Now, how can the weight of a galaxy be inferred from the velocity of its stars? It's similar to estimating a crowd size based on how quickly people are moving. Using the data from Gaia, astronomers calculate that the total mass of the gas, dust, stars, and that elusive dark matter in our galaxy is about 200 billion times that of our Sun. The dramatic twist is that it's roughly 5 times less than we initially believed, despite the fact that it sounds like a cosmic heavyweight. We might have been a little too aggressive with our dark matter estimations, according to one idea to solve this cosmic puzzle. There may be less dark matter in the universe than scientists previously thought. It's similar like discovering that your cosmos soup contains fewer ingredients than you initially believed. But wait, weighing a galaxy is infamously difficult, like nailing jello on a wall. Our cosmic measuring tape may need to be adjusted, or there may be some anomalies in the Gaia data. Nevertheless, several study groups have joined the celestial probe, and they all appear to be humming the same cosmic melody. If this cosmic discovery is correct, it would be like opening a new chapter in our textbook on cosmic physics, a revolution that could force us to reconsider not only the Milky Way but the entire universe's starry regions. This could be a cosmic game changer, says Stacy McCall, an astronomer at Case Western Reserve University. Travel back in time to the 1970s, when astronomer Vera Rubin embarked on a celestial expedition with her cosmic crew. Their objective? Investigating other galaxies' star grooves. According to the Cosmic Playbook, stars on the periphery of a galaxy should be cosmic slowpokes in contrast to the fast-moving stars close to the center, just like Mercury is the cosmic speedster and Neptune takes its sweet time around the Sun. The storyline changes at this point. A cosmic surprise was discovered by Rubin and her team of astronomers. Stars in galaxies far from the cosmic dance floor were strutting their thing almost as quickly as those closer to it. Imagine a disco in space where everyone is moving to the same beat, regardless of where they are. The existence of dark matter, the unseen heavyweight champion that creates these enormous halos around galaxies, was alluded to by this cosmic discovery. Consider early astronomers like Copernicus and Kepler. Although we have gone a long way, we are still the novices, gazing in awe at cosmic wonders and attempting to unravel the mysteries of the cosmos. Swirling around the Sun with a slew of stars in our small galaxy, Earth is like a tiny island in the vast ocean of space. At the heart of scientific investigation is our search for purpose among the stars. This curiosity keeps us traveling into the cosmos even when the answers surprise us. It's a never-ending journey in which each solution raises new queries, ensuring that our cosmic exploration never comes to a conclusion. We appreciate you viewing another InfoPaper episode. Make sure to click the video on your screen while you're still here.